Statistician of the Stars. I want to look at the last call for alcohol cancer papers. I want to remind us of this ubiquitous, scrofulous, terrible fallacy that just plagues medicine. Good pun. Not that good, but it's a pun anyway. It's the epidemiologist fallacy. Now, those who've been following the class have seen me go in great detail of what the epidemiologist fallacy is. So I'm not going to belabor that. I have links if you want to go and look at the specifics of it. But it's very simple. It's when a scientist says X causes Y, which is what science should be doing. They should be saying X causes Y. That's the goal of science. But X is never measured. So how do they do it? What's the trick? Well, they invoke the we p fallacy, where the we p fallacy, and again, we've proved this to death. I have, I don't know, like a half a dozen posts proving that every use of a p-value is fallacious, without exception. Anyway, the we p, when you see one, means cause. So how do they get away with this? How do they get away with papers that say, I can see there's a lot of confusion about p-values. A lot of people are just devoted to it because they still believe in the pagan magic of probability, that probability is a real thing and so forth. And that's very hard to shake. I get it. But this one here seems real easy, to me anyway. When you say X causes Y, but you turn out not to measure X, well, you'd think that they would get away with that. But just as you do that, some fat, hairy scientist comes up, starts waving his P in your face and says, look how small it is. And then you're just beguiled. Oh my God, that is a pretty small P. Must be true that X causes Y. Well, most of the time, people don't read beyond the propaganda headline that says, in this particular case, alcohol causes cancer, drinking causes cancer, and so forth. Oh my, we have another study that shows alcohol use is associated with or causes cancer. Therefore, it must be true because it was done by sober scientists, another pun, at prestigious universities, in this case, written up in The Lancet Oncology. And here's the paper that we're going to be looking at. Again, you can go to wmbriggs.substack.com or eliminate the Substack and get the full write-up of this. I'll have a link down below. And thanks to Dr. Anand for contributing this. The peer-reviewed paper is Global Burden of Cancer in 2020 attributable to alcohol consumption, a population-based study by Harriet Rumgay. They ask us to believe a temperance paper was written by someone named Rumgay and a bunch of others. Well, attributable, meaning caused. And later they actually use the word cause, so it's not just me imputing their motives. They actually say alcohol causes cancer. So that's X causes Y, alcohol causes cancer. There's our X causes Y. Now, to even think about proving that, you can't just look at somebody who takes a drink and gets cancer and say, well, there it is, they've got cancer because of alcohol. And then you look at another guy who never drank in his life, a teetotaler, and he doesn't get cancer, or a group of them don't get cancer at the same rates as those who do get cancer. That's a correlation. And I've told us a million times, every scientist will tell you that correlation does not imply causation, unless it is his correlation. And then it's obviously causation. So everybody knows the rule. Everybody violates the rule when it comes down to them. But the rule is still the rule. You don't get cause out of this. Finding the correlation is only the very first step in trying to prove a causation has occurred. And we've gone over that in the class 100 times, so I won't belabor that. Now, here's the thing. Did Rumgay, what a name, Rumgay, the poor woman. Did Rumgay measure people who drank and did not drink, or the amount of booze that people have drunk, or beer or wine or whatever, and then look at whether or not people got cancer? That would be the start. Did she do that? She did not. Not only did she not measure X, she did not measure the amount that people drank. She did not even measure Y. We have the double epidemiologist fallacy here. She did not measure X and she did not measure Y, but she says X causes Y. So here's what she did do. I'm going to read you this from the paper. This is my emphasis here. I'm going to quote, country-specific estimates of incident cancer cases were extracted from some database for lip and other cancers. Okay, end quote. Next, quote, alcohol consumption estimates for 2010 were obtained from another database as adult per capita alcohol consumption in liters of alcohol per country, per year by country, disaggregated by age. Now, I emphasize the estimates. Look, if countries could catch cancer, if cancer can be caught, then maybe Rumgay's analysis makes sense. But countries can't catch cancer. Only individuals can catch cancer. And even if they could catch cancer, countries, Rumgay's analysis doesn't make sense because she doesn't even have direct measures, but she only has estimates of them from these databases. And these estimates will come with substantial plus or minuses, which must be incorporated into the analysis, which they didn't do. And therefore, we would have substantial uncertainty even if we were trying to say that certain countries caught cancer, so based on these things. Now, so how did she fool herself so badly? I mean, we could look at this stuff, but there's absolutely no use in doing so. It's not justified what they have done. Their evidence is wrong. We should not be, if you were in a court of law, you would object to the judge and say, we can't even look at this. It has nothing to do with what they claimed it is. And we would exclude this evidence entirely. We wouldn't go in and look at the thing, because once you do, you're going to look at their pictures, and I'm going to tell you about another thing here in a second. You're going to look at their pictures. Oh, look at that picture. This country over here is darker, meaning more cancers, and this one over here is lighter. Then you're going to begin to tell yourself stories. Yeah, you know, I know a guy from that country. Boy, they drink a lot over there, boy, and they have a lot of cancer. And you're going to start telling yourself these just so stories to justify this stuff. And it might be true that alcohol causes cancer. I'm not saying it doesn't. I don't know. That's the point. We can't tell from this data. This is only the absolute barest beginning of looking at this stuff and finding out what else is going on. And I've tried to explain this to you 100 different ways. You can go again, look at the website, Spurious Correlations. Spurious Correlation by a guy named Tyler Vegan. He's got, I don't even remember now, 2,000 of these things. Just exactly this kind of stuff. 2 different series of numbers, and they all sound preposterous. The only reason we keep this one and put it in the journal is because it doesn't sound so preposterous. But they prove it in exactly the same way. All those correlations he proves are causes. He proves in exactly the same way as this. So how do we know to reject those and we accept this? It must be that we're using evidence in an entirely different way, and that you have to use the class. Basically, they immediately forget all of the caveats that they themselves put on, and they have this nifty equation, which might look intimidating to you. You can look at it up online yourself. It involves ratios of integrals of these various mathematical objects and so forth. And to some people, they think, "Ooh, wow, that's pretty cool, man. That's some math going on there." And therefore, it turns it into science. We got the software to do all that kind of stuff, and that's exactly what they did. And they're beguiled by the software and their facility with using it and so forth, and then they end up writing their conclusion. Now, here's what they claim. Here's what Rumgay claims. Quote, globally, about 741,000 or 4.1% of all new cases of cancer in 2020 were attributable to alcohol consumption, end quote. And later, again, I'm trying to emphasize this, quote, we found that alcohol use causes a substantial burden of cancer. First of all, that's a mighty precise number, the 741,000 or 4.1%. But too precise. They don't take into account all their pluses and minuses. And it can't be believed. I mean, again, you could go and look at all of the, you could take the cancer database that they have and look at any of these other increasing things, you know, free trade and what's going around the world easier now, computers or something, or chips of a certain size. And you could say those are causing cancer. They would be exactly the same signal as alcohol, more or less, plus or minus. Increasing as alcohol use is increasing because of globalization has made it easier to produce and export this stuff everywhere. And then you could say, using exactly these same tools, that computer chip manufacturing is causing cancer, or anything else that's doing this. And it would give you the same exact signal. So you can't do this kind of stuff. It should not be published, this stuff. Again, I tell you, there's too many scientists, there's too much money in science, and they're pumping out this kind of stuff, which then other people take seriously. And this becomes the basis of decision making, when in fact it should have been tossed out from the very beginning. If you want to learn more, take the class. It's free. Or go to, or you can find it, all this kind of thing, at wmbriggs.substack.com, and I'll have links down below. Thanks for listening.